All right, so it says, what is the temperature change of 120 degree, or 120 gram, so that's my mass, piece of aluminum whose specific heat is 1.89 joules per gram degree Celsius. Just want to remind everybody that when we say 1.89 joules per gram degree Celsius, we really mean 1.89 joules per 1 gram 1 degree Celsius. So anything that's underneath, or the denominator here, is always going to be 1. Okay? And so that's what I have written out here. Kind of change it into a for every statement for you. So it means for every 1 gram of aluminum to change 1 degree Celsius, 1.89 joules of energy are required. Okay, and we don't have, if we only had 1 gram and we only wanted it to change 1 degree Celsius, we'd only need this many joules. Okay, and joules is just a unit of energy. But we don't have 1 gram. We've got 120 grams of aluminum. And we don't want it to change just 1 degree Celsius. We want it to change, we don't know how much it's going to change. And then we're going to say, okay, look, well, this is 1,800 joules of heat or energy. Okay, so now I got to figure out, okay, well, this is getting bigger by 950 times. And this is getting bigger by 120 times. Okay, and I really have a couple things I got to figure out. I'm doing both by delta T. Delta T is the thing I'm solving for here. And then I've got to figure out the relationship between mass and energy. Okay, so when mass is constant, if I add a bigger amount of energy, which one has the greater change in temperature? Well, the one with more energy, this one, has a greater delta T. So as the energy went up, the delta T went up. That's a direct relationship. Okay. Now, if I have the same amount of energy, that's the constant in this graph, right? I have the same amount of energy, and I change the mass, which one has the greater change in temperature? Well, it's the one with less water. I think we all kind of know that. So as the mass went up, the delta T went down. That's an inverse exponential. So what that means is that mass, we just said, was inversely related. So this is going to be divided by 120. And conversely, this one, Q and delta T, those are direct. So this is times 950. So we got 1 times 950 divided by 120. And so we've got 950, oops, sorry about that. We've got 950 divided by 120, that's 95 over 12. And if you kind of just, that's kind of like 96 over 12, so it's around 8. It's a little bit less than 8 degree temperature change. Okay, problem 12 says, a beaker containing 250 grams of water is heated with 1,500 joules of energy. If the temperature of the water is changed from 22 degrees Celsius to 23.4354 degrees Celsius, what is the specific heat? So this time I gave you, all right, well, specific heat just means how much energy does it take to make 1 gram of whatever substance you have, in this case water, to change 1 degree Celsius. It takes blank joules of energy. Okay, all right, so our first for every statement, well, I don't have 1 gram, I've got 250 grams of water, because 1 gram of water is a little tiny. It's that little 1 centimeter cube block to change. And how much do I want it to change? Well, I want it to change 1.4354 degrees Celsius. And that takes 1,500 joules of energy. All right? So 250, to get to 1, we'd divide by 250. And to get to 1, we'd divide by 1.4534. Well, 4354, sorry about that. Okay, and we know from our last problem that M, and oh, actually this is different. M and E, and E and delta T. Okay, so let's think this through. Let's do this one first. Delta T and E. So mass is constant here. And we add a little bit of energy to this one and a big amount of energy to this one. So as energy went up, what should we expect about the delta T? Well, if these two have the same amount of mass, we should expect that the one with the higher one is direct. And on the other side, mass and energy. All right, so that means that delta T is the same. This is a little bit harder to kind of picture. So if I increase the mass, do I need more or less energy to get the same change in temperature? Well, I need this to be on a bigger stove than this one. So as I increase the mass, I need more energy to make sure that delta T is constant. So this is also direct. So I'm going to take this number and I'm going to divide it by 250. I'm going to take that and divide it by some crazy number, 1.4354. So 250 goes into that 6 times, and 6 divided by 1.5 is about 4. It's a little bit more than 4 joules. So if you put that in a calculator, you'll probably get the right answer exactly. And the last problem. Let me just clear out some space here. Oops. Okay, so this says heat energy equivalent to 25,000 joules is applied to a 1,200 gram brick whose specific heat is 2.54 joules per gram degree Celsius. What is the change in temperature of the brick? I gotta tell you, the only time change in temperature of a brick is ever alluded to, crazy science problems, right? But we don't know the delta T then of this. So we know the specific heat. My eyes should light up when I see multiple units because these multiple units give us a forever statement. They say for every 1 gram of brick to change 1 degree Celsius, we need 2.45 joules of energy. Okay. Well, if I had 1 gram and I only wanted to change it 1 degree Celsius, then this is how much energy I'd need. I'd be done. Do I have 1 gram though? Yeah, I got a lot. Bricks aren't 1 gram. It's 1,200 grams. 1.2 kilograms or about 2 to 3 pounds of brick to change. And I want to know, I have no idea how many degrees Celsius it's going to change. We need, and this time I got 25,000 joules of energy. All right, so I'm going from here to here. I got times 1,200. And I got from here to here, it's times about 1,000, 10,000. Okay, so now I got to do delta T compared to energy and delta T compared to mass. And from our last problems, and I think I showed you this before, we know that those two are direct and inverse respectively. So this is times 1,200, and this is divided by 10,000. Oops, sorry, backwards. Times 10,000 divided by 1,200. Okay, because this one is the inverse one. So 10,000 divided by 1,200 is the same thing as 100 divided by 12. And that goes in 8 with 4 left over. That'd be 8 1/3. 8.33 degrees Celsius. And the last part of the problem says, hey, look, if we got a brick, all right, I'm just going to write out that forever statement again before I forget it. For every 1 gram of brick, to change 1 degree Celsius, we need 2.45 joules of energy. Okay, and then it changes, well, it goes from 25, and we don't know the final temperature. Uh-oh. Well, we know the brick was 1,200 grams. We're going to assume that it's the same size brick, and we don't know. Oh, I guess we do know the change in temperature. We already did all that. Okay, so the change in temperature, let's go back up here. The change in temperature was 8.33 degrees Celsius. This is actually a lot easier than we thought here. So it's just 25 degrees. It's just this 25 degrees Celsius plus 8.33 degrees Celsius. So that's 33.33 degrees Celsius. Now, we got a choice here. Here's the thing. This is at 25 to start, and we need, if the heat is applied to it, which it says that it is, I think, in the back problem here, right? So it says heat energy is applied, right? So that means that we added heat to the brick. Then we know that this is additive, right? But what if it said we took away 25,000 joules? Well, that means that it's not plus, it would be minus. But in this case, they did say that it was added, so it's plus. So here's our final answer. Hope that helps.